So we have to start talking about polynomials as our title of our next unit. So this piece of paper will be going in your notes section. However, we'll do that next class. So I want you to treat it like it's your notes and go ahead and highlight your title. So in this unit, we're going to need to remember our exponent properties. So I'm going to, I nicely highlighted that, and I'm now going to zoom in so we can talk about all of the different properties. So the first property, and I might also go ahead and highlight all of these so we have them. So product of powers, quotient of powers, powers of powers, negative exponents, and zero so as an exponent. So I'm going to go ahead and I'm going to talk about product of powers. So what the product of powers tells me is if I have two variables that are raised to a certain power, so x to the n times x to the m, I can add my exponents together and do n plus m. So we've been doing that one all along, no big deal. The quotient of powers is if I have x to the n over x to the m, I take them and I subtract my exponents. So if n is greater, it's going to be on the top of the fraction, and I'm going to do n minus m. If m was greater, it would be on the bottom because the bigger exponent's on the bottom, and then I would do m minus n. Powers of powers is when I have an exponent and I raise it to another exponent. So x to the n to the m. That means x to the n times m. So when I have a power raised to a power, all I do is I multiply my exponents. The next one is negative exponents. So if I have x to the negative n power, what the negative exponent does is it turns this into a fraction. So it turns this into a fraction and it moves it to the other side of the fraction. So right now, if I were to turn this into a fraction, it would be this over 1. So what it does is it moves it to the other side. So right now, x to the negative n is on the top, so I'm going to move x to the negative n on the bottom, and when I move it to the other side, the exponent changes to positive. And then since I have nothing left on the top, it turns to 1. If x to the negative exponent was on the bottom, it would then be moved to the top. So 0 as an exponent. So if I have x to the 0 power, it always equals 1. Anything to the 0 power is always equal to 1. You've learned this in Algebra 1, but just as a nice refresher so we have it in our brains. So now we're going to have some problems where we're going to simplify each expression using these laws. So x squared to the third power, since it's a power of powers, I'm going to multiply them. So I have x to the sixth power, and I'm done. You never want to leave your answers in a form when you have a negative exponent or if you have multiples of the same variable. So if I have x and x squared, I have multiples, which would mean it wouldn't be done, which is why you always want to make sure you're finished. If I look at this next one, notice this negative 8 has an exponent of 1, and this negative 8 has an exponent of 3. So multiplication's between them, so I'm just going to add them together. So negative 8 is my base, so it stays the same, and then I add my exponents to the fourth power, and that would stay in parentheses. So then because those are all numerical answers, I can go ahead and simplify that. So 8 to the fourth power is 4,096. If I look at this next problem, I notice a couple things. I notice I have multiple x's, and I also notice I have a negative exponent. I personally deal with negative exponents as one of the first things I deal with. So I'm going to turn this into a fraction, and I'm going to circle my negative exponent, and I'm going to bring it down. So I have x to the fifth and x to the third on the top. So if you want to, you can go ahead and clean that up, which makes x to the eighth. And on the bottom, I'm going to have x to the sixth. So now I have to clean this up one more time. So I notice the bigger x is on the top, so x is going to stay on the top. And now I just subtract my big number minus my little number. So 8 minus 6 is 2. Notice nothing's left on the bottom, so I don't need the bottom. I'm done. Let's go ahead and look at number 4. Number 4, a lot's going on. So I notice there's nothing but multiplication between everything. So now I see my negative exponents and I go, okay, I want to move those to the bottom. So I'm going to say 7x squared z to the 5th over y to the 4th z to the 1st. So the only thing I can now clean up are my z's. So I have 7x squared, and then my z's, my bigger z is on the top, so z is going to end on the top. And now I just subtract my exponents, I get 4. And on the bottom, I have y to the 4th. If you do this a different way, that's completely fine. That's no big deal. So now, if we do number 5 together, I'm going to take this 2, and I have to essentially distribute it to everything inside my parentheses. So this is going to be s to the 8th, and this is going to be t to the negative 8. I know I'm not done because I have a negative exponent, so I have to move it up. So s to the 6th and t to the 8th, and I'm finished. So I want you with that idea to try to solve these last 3 problems on your own, and then we'll go over them next class. So when we enter the polynomial world, we have a bunch of vocabulary words that we have to know. So we need to highlight these, and I went ahead and I wrote down all of these definitions, but you really need to know what they mean. So a monomial is a number, like 5. It's a variable, like x, or the product of a number of one and or more variables. So I could say like 5x. That's what a monomial would be. A polynomial is a monomial or a sum of monomials. So like I could say 5 plus x plus 6y minus 2xy. That would be an example of a polynomial because it's multiple monomials added and subtracted together. We also have the vocabulary words binomial and trinomial. A binomial is 2 terms, and a trinomial is 3 terms. So terms are just monomials. A binomial is 2 monomials, so a binomial will be like 2x plus 5. A trinomial is 3 terms, so 4x squared plus 5x plus 3. That would be an example of a trinomial. We now have what's called the degree of a monomial. The degree of a monomial is the sum of the exponents of all its variables. So if I have this example, 5x squared y cubed, the degree is the sum of its exponents. So my exponents are 2 and 3, so the sum is 5, so my degree is 5. If I have a 5x, my degree would just be 1. If I had the number 5, notice I don't have any variables, so I don't have a degree. This has a degree of 0. The degree of a polynomial is the greatest degree of any term in the polynomial. So like if I come up and I look at this example, 5 has a degree of 0, x has a degree of 1, 6y has a degree of 1, but 2xy has a 1 and a 1, which makes a 2, which means the degree of this whole polynomial would be 2. The biggest degree is 2, so my degree on that one would equal 2. If I had 4x cubed plus 7xy minus 6x plus 3, let's look at this one. This has a degree of 3. This has a degree of 2 because I have 2 variables. This has a degree of 1. 3 has a degree of 0 because there's no variable. So the biggest degree that I said was 3. So my degree of that polynomial is 3. So the other really important thing that I want to stress, that I want to put somewhere, that I'll erase since I don't have a lot of room, is that in order for something to be a polynomial, it has to have a degree greater than or equal to 1. So if I write that down, all polynomials, and you can write this down anywhere you want, but just make sure you put it somewhere because it's important. All polynomials must have degree Actually, that's not true because it can be a degree of 0. So, however, they always have to be whole numbers. So let's make it that way instead. So degrees always have to be whole numbers. So most of the time it starts at 1 or greater, but you can't have a degree of 0. Sorry about that. So all polynomials must have a degree that's a whole number. So no negatives, and so no negatives. And no decimals. So let's go ahead. Oh, and then if we come back down, we missed 2 vocabulary words. Standard form of a polynomial is a polynomial that's written with descending powers of x. So that just means biggest degree to smallest degree. That's all that means. So standard form, biggest degree to smallest degree. And then the last one is the leading coefficient, which we talked about. The leading coefficient is the numerical factor of a monomial with the highest degree. So my leading coefficient is the coefficient with the highest degree. So if I come back up and I look at this right here, my highest degree was this guy, so it's my leading coefficient. So the coefficient would be 4. So let's go ahead and look at some of these problems. So this problem wants me to go ahead and put it in standard form. So to put it in standard form, I have to find the biggest degree first. So I'm just going to write f of x equals, so negative 7x to the 8th. So I used it, I'm going to cross it out. The next biggest degree I see is 4, so negative 2x. My pen doesn't like writing the number 2. 2x to the 4th. And then I have negative 6x cubed. And then I have 5x squared. And then I have positive 4x and negative 5. All right. So now what would my leading coefficient be? So my leading coefficient is the one in front, so negative 7. My degree is 8, because the biggest exponent is 8. And my constant, hopefully we all know what the constant is, negative 5. Your constant is the number that doesn't have the variable. It has a degree of 0. All constants have a degree of 0. So pause this video, try example 2 on your own. So for example 2, I got to first put it in standard form. So it's going to be 2x cubed plus 5x squared minus 4x plus 7. So my leading coefficient is 2. My constant, oh no, my words aren't going with it. My constant is 7. Here, let's do that. Constant is 7, and my degree is 3. Let's make sure I answered everything. Yep. Perfect. Flip your paper. All right, so now we have to talk about the names of these functions, because with a different degree, the degree determines the shape of the graph as well as certain characteristics pertaining your graph. So remember, I always would tell you that if I had an equation without any exponents, like y equals 2x plus 1, it doesn't have any exponents, it makes a line. If I have an exponent of 2, it makes a parabola. If I have an exponent of 3, it makes your cubic function. So we have these different names because the degrees determine which function they are. So I'm going to highlight all of these. So a degree of 0, we already talked about it last page. We said the degree of 0 is called a constant. My pen is not choosing to work today. Let's try the other side. Hold on one second. It is the constant. So an example would be 0, 5, 6, 3 over 2. Anything you can think of would be a constant. A degree of 1 means the biggest exponent is 1, so that would look like y equals 3x plus 2. That would be a linear function. With a degree of 0, that's called a quadratic, which we've just been doing, which is like y equals x squared plus 4x plus 3. That would be an example of a quadratic equation, or a quadratic degree. So when you have a degree of 3, that's cubic, which can look like anything with an x cubed. So y equals x cubed plus 4, y equals x cubed plus x squared plus x plus 1. Anything with a degree of 3 would be a cubic function. Anything with a degree of 4 is what's called a quartic function. And again, it would be anything with the biggest degree of 4, so x to the 4th plus 2x cubed minus 6x squared plus 2x minus 4. Anything with a degree of 5 is called quintic. So this equation, it would be anything with the biggest degree of 5, so x to the 5th plus x plus 1, or any of them all the way descending all the way down. So looking at these examples, I want to know whether or not they are a polynomial. If it's not a polynomial, I want to know why not. So if I look at this first example, I want to know if it's a polynomial. So yes, it is a polynomial. No, I lied. No, it's not a polynomial, because notice that has a degree of -1, and you can't have negative degrees. So no, because all polynomials have whole number degrees. If I look at the next one, x to the 4th minus 4x minus 1/4 x squared plus 3, yes, because all of my degrees are whole numbers. And if I look at my last one, this has a whole number for a degree, but notice this one, x squared's on the bottom. How would I move x squared to the numerator? Well, if I put x squared to the numerator, it would be x to the -2, right? Because when you move things. So no, this isn't. Same reason. All polynomials have whole number degrees. So looking at these examples on below, you're going to classify each type of polynomial by degree and by number of terms. So my biggest degree in this problem, that has a degree of 2, this has a degree of nothing, degree of 1, this has a degree of 3. So I'm going to classify by its degree. So because it has a degree of 3, I'm classifying it as a cubic function. And the number of terms, let's see, it has 1, 2, 3, 4 terms, which is called a polynomial. If I look at this one, this has a degree of 3, this has a degree of 0, this has a degree of 3, and this has a degree of 5. So the biggest degree is 5. So my degree, if I classify this, is quintic. And the number of polynomials, or I'm sorry, number of terms. So if I look at it, it looks like it has 4 terms, but notice this and this could be combined, which would then make it 3 terms, so this is called the trinomial. So this is where we're going to stop. So this is called a trinomial, so this is where we're going to stop so we can keep going next class. This is called a trinomial because I can combine these two together and combine like terms, which would then shrink my 4 terms down to 3 terms.